To be honest with you, I didn't choose chemistry. Chemistry chooses me. Because I was given a scholarship by ESO in the early days to study chemistry in the University of Malaya. And I needed the scholarship. So that is why I ended up doing chemistry. But all along, I've been interested in chemistry anyway in the school. In fact, I was the only candidate in the I think must be 64, who obtained 4 A's. In those days, 4 A's for S, those are the, what do you call that? Those must be the higher, what is it? Not STPM, the formal STPM. I cannot remember the name now. All right, A level. A level. I was the only one who got 4 A's from Penang State. All right, and I was given the scholarship by ESO to actually do chemistry in University of Malaya. So I ended up doing chemistry, yeah, but I developed the passion for it following that, yeah. Actually, in those days, the only person who I idolized was actually Einstein. Yeah. But Einstein actually did a lot of what you call that physical chemistry as well. He actually did a lot of chemistry, but in the physical aspect. So actually, I ended up doing my PhD in physical chemistry on latex, yeah, on polymer science, yeah. Okay, in fact, I was selected by the Malaysian Rubber Board in 1968 to follow a program on colloid and surface science in Bristol University. I was the first to be selected to actually work on this because, as you know, Malaysian Rubber Board is actually the one who, the parent body of RIM, the Rubber Research Institute of Malaya at that time. They deal with latex, natural rubber latex, and at that time very little was known about the colloidal properties of natural rubber latex. And in fact, I was selected to actually undergo a training in that area. So that's how it came about. And in fact, the industry itself on the latex in those days was still in its very early stages of development. We have not really gone into the very important industry of glove manufacturing at that time yet. So this actually came about much later. And in fact, the training in the colloid science and the subsequent development of this particular branch of chemistry in the university by me and following by the other university in the 70s enable the industry to come up with a group of, what should I say, the technical people who were able to man the industry later on, which developed into a multi-billion industry, as you know nowadays. Glove manufacturing, Malaysia is the largest manufacturer of medical glove in the world, and it's actually a major earner for the country in terms of export. I think that speaks itself. Yeah, speak for the industry itself, yeah, how important it is. In fact, to tell you the truth, the industry is undergoing a major, what you call that, transformation. As you know, natural rubber latex used to be our forte. And in fact, it still is, but at the same time, because of the glove industry, it has attracted the major synthetic latex producer into the country. And they have actually spent billions, I think, in developing this synthetic rubber latex industry in Malaysia itself. The major companies are in Kluang and also in Pasir Gudang. They produce the largest amount of synthetic latex for the glove industry, not only for us, but also for export. And the glove industry itself is developing very rapidly into a very high-tech, what you call industry, to becoming a very high-tech industry, because this is an indigenous industry actually developed by Malaysia. And we should be proud of it. Okay, indigenous industry in the sense that in the early days, dipping of glove is actually, we have to learn it ourselves. There was nobody else who can teach us on that. So the industry actually learned through trial and error, and a lot of what you call that early days, what you call that failure, and through very hard work, and through this crop of what you call that latex scientists that I mentioned that was trained both locally and overseas, who actually taken up what you call colloid and surface science to actually develop into the core people or the technical people who actually man the industry, who actually contributed towards the development of the industry in terms of technical know-how. And this is what I meant. And in fact, now the gloves industry have moved to such a what you call advanced stage where we have introduced a lot of automation into the what you call the dipping industry, and the glove itself had actually gone into very high what you call quality in terms of what you call that functionality, in terms of the materials usage, and also in terms of going into green what you call that technology, in the sense of energy conservation, in the sense of making the gloves lighter so that you can conserve materials. So all these are actually developed by our own what you call that technical input, not from overseas, or by our own scientists and technologies. This is something we should be proud of. Yeah. In fact, I think, let me give you a little background to that report. In fact, we have always realized that our school, what you call that, school children are really not that well versed with their science and mathematics, and many of them do not opt to take science and maths in their school. So in order to find out the actual cost, the reasons for these what you call that students being not interested in science and mathematics, we have actually organized 2 workshops. The academy have organized 2 workshops with input from the teachers, with the stakeholders who are actually running the schools, with the teachers, and also the people who actually support the what you call the teaching what you call profession. And in fact, it is through these 2 workshops that we found out that there was a big gap between the teaching and learning of science and maths in schools. You have the what you call that urban area schools, I think, where the students are in fact, I think, good in terms of the what you call pursuing science and maths, but you also have the very poor facilities and also the students' quality and the conditions of the facilities. I think it is some of them, when you look at the pictures, is actually very what you call disturbing, in the sense that the school children every day go to school without having any school what you call no shoes, and then they have to travel for miles, in fact, to get to the school by boat, trekking through the jungle. And the school's conditions, I think, when you look at it, it is actually very rudimental, all right? Many of the facilities are not available, and these, of course, are in the interior, what you call area in our Sabah and Sarawak, okay? But in the urban, I think, schools, the conditions are in fact a lot better. But still, we still have what you call that issues about the generating the interest of the what you call student, in terms of making the teaching more fun and interesting. And I think this is still I think lacking in terms of how the teachers can make their lessons more interesting and fun for the student. And we also found out that many of these what you call that schools are not really running the hands-on to what you call that practicals for them. And this is in fact, I think, how the what you call students find that it is actually everything learning from books, and is therefore not so fun in terms of generating the interest for them. All right. And in fact, based on that two workshop, we have actually produced a advisory report, and I understand that report have actually gone all the way to the PM and also the DPM, who is also the Ministers of Education. And hopefully some of those, what you call that, recommendation that we have put in the report will be taken up in the, what you call the national blueprint for the education, all right? Important thing is they must have the, what you call passion to do all this. They should be led by their passion, all right, to actually pursue what they are supposed to pursue, all right, in science and also in technology. Because both of this will be able to, in fact, support the economy later on. Without the fundamental understanding of science and technology, all right, there will be no new economy, there will be no new, what you call, industry. So we have to rely on the young scientists to come up with new, what you call that, understanding of processes, of new materials, so that they could eventually be applied to the industry. However, I think I must mention that we should not be overemphasizing on commercialization, all right? We should be driven by the urge to generate knowledge, all right? And from there, application will come later on, all right? There are many examples where the, what you call that, the application came very much later after the invention or discovery of a certain theory. Laser is a very, what you call that, example, is a very common example you can think of, all right? When the laser was first invented, nobody thought about all those applications that we are using it now. But you just look around today, without laser, many of the things doesn't work, all right? Handphone is actually another good example, all right? Many of those things that we talk about there actually was generated. The discovery was actually done a long time ago, but nobody actually understands those things. And then, of course, let alone application. All this came much later. The knowledge generation itself is important.